let's talk about the next part here. So printf here, open parentheses, quotes, checking for sockets ready, colon, dot, 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 /n, quotes, close parentheses, semicolon. So let's see if any of the sockets are ready to go. Now remember, these sockets, if they're ready or not, has to do with what? The client, of course. And so we say if here SDLnet underscore check sockets, socket set, comma, uint32, close parentheses here, -1, close parentheses, equals -1, close parentheses. Oh my gosh, what does all that mean? Alright, so SDLnet underscore check sockets. What this does is it says, hey, is there been any data sent to us to the clients, right? Has any interaction happened with any of these sockets? If so, we need to probably do something about these. Okay, so that's what we're doing. We're getting that those values here. We're saying uint32 -1 in order to get our range here of values for how many sockets we're dealing with here, and then we're doing our socket set here that we have passed in. And if we have a -1, of course, we have an error. So fprintf here, inside the curly braces, open parentheses, std error, comma, quotes here, SDLnet underscore check sockets, colon, %s, so we can see our error message, /n, close quotes, comma, SDLnet underscore get error, open close parentheses, semicolon. Okay. So if there is an error, it's going to let us know that it was when we were checking the sockets, and what the error was. That's what the %s is going to do when we get the error message here. Okay? Cool. So let's do the next one. Let's actually check to see. Now we know that we did a check sockets here, so we found out, which sockets have been, well, basically, which ones have been accessed, which ones have sent information to us. And now we need to do something about that. Okay, now this is where it gets a little more complicated because we're dealing with the STD, which is standard lib here, standard library, sorry, put it away, for C++, for dealing with the list. And we have to use some more advanced functionality here in order to loop through blocks of memory at a time. Just the way we would, say, an array or something like that, with a real simple set of values. And we'll get over how to do that here in just a second. Okay, so printf here, checking for messages sent by clients, ... I just let myself know this whenever there was, that I'm checking for the messages sent by the clients whenever I'm going into that. I did this for debugging purposes. Up to you whether or not you want to put it in. Alright, so for open parentheses here, std : list, open greater than less than signs, client type here. Remember, that's the struct that we created at the beginning for defining our clients. : iterator. Alright, iterator is something special inside C++, which lets us basically jump between the different memory addresses for blocks of data. So for instance, we can do class objects into a list, and then we can actually loop through those class objects in a list in memory using an iterator here will let us do that. Because normally you couldn't just do that. Normally you couldn't just load it up like you could an array. This makes it really fast and efficient because this way we're doing more like a it just jumps through between the linked list points in memory really quick, and this lets us cycle through it and treat it like you normally would a regular count variable or something like that. Like I++ or count++ or whatever you want to do for your for loop. So, typically you would do something like, for instance, typically this for statement here, right at this point here, you'd say int something like count here, equals 0 semicolon, something like that, right, for initializing it and starting it and creating your variable for your loop. That's exactly what we're doing here. We're doing std here for scoping it because this is part of the standard library for list. We're doing the type is list here. So this whole thing is the same thing as this type here, like int, but it's for lists inside the standard lib object instead for that type, for the data type, for that class list. Okay, and then here we're saying what type of variables are going to be stored in our list, right? What type objects? So what's the data type for that? In this case, we're doing a client type, which is our structure up above. Now, if you remember right, up here at the top, we have our client type struct, and so that's what we're saying is the data type in our list for our iterator. And okay, so here we are. We're back here now, and colon here, because we're scoping all this, right? Remember, colon is scope. So that way we don't have a namespace collision, which I'll get into in a second. Alright, so we're going to scope these out, and that lets us know what type of iterator to make. Because you can make, iterator is really smart. You can set it up to be any type of iterator you want, and it'll automatically conform itself to your setup. So basically we told it we want the iterator to be type list, iterating through client type data types sitting in there for each object. Alright, so this whole entire thing right here is the int. No kidding, that whole thing is basically your data type, just like int is. This whole thing is a data type. This whole thing describes one massive data type. Alright, here's the name of our variable. Now here I named the variable count, see? Just like this. Okay, so now I'm naming it because it's an iterator, it for iterator, read clients, because what I'm going to do when I'm looping through here, I'm going to be reading in my clients, the data from my clients. Does that make sense? So I'm going to say it read clients. Let me move my cursor so you can read that. It read clients, alright? Equals clients dot begin, open close parentheses, semicolon. Okay, that would be the same thing as this right here. I know that sounds crazy, but it is. Basically, clients.begin, we have to have the beginning memory address for the first object in memory, right? And it's not going to know what that is unless we tell it where to begin. So this lets it start at the beginning data structure in memory, start looping through it, where we begin in memory, and then that basically sets it to that first memory address. And that'd be the same thing as you normally would be is 0, where you're setting it to the first memory address in your array, or something like that. You know, where you're saying 0 here, it's going to be the first element in your array, right? Well, we're saying this is the first element in our list, right here. And we're saying clients.begin, because if you remember right, we defined a list called clients. So check it out. Where is it? Where is it? Where is it? Yep, right here. See? So we created an std : list here, and we did a type, so it's type list with data types being able to store it inside of that list. Think of it like an array. Client type data type, which is the struct up here, remember, for each client. And we called this wonderful variable list with this type of capabilities clients. So when I am back here and I am telling this thing clients.begin, I am telling it the beginning memory address inside of this list for that first data element, which is of type client type. Alright? For our data type in there. And that points to that first memory object inside of the client's list. So it knows where to iterate through. It knows what it's iterating across. Cool. Alright, the next part. When you do your loop, typically the next thing you're going to do, right, it's going to be something like count is, while count is, greater than, I don't know, length, say len of, I don't know, array, I don't know. So right, so the length of your array, right? Something like that, and then you do a semicolon. And I'm not saying, maybe your array is called array, right? And you're finding the length of it or something like that, right? Or total count of the array or whatever it is you want to do, right? Whatever, right? This is the maximum number which you can loop around, okay? And so you're saying, while count is greater than that, cool. Or shall I say, until count is greater than that, or whatever. In our case, it's going to be a little different. It's going to be the same thing pretty much. So again, we have it read clients, right? Because we defined it right here, right, for the name. So continue on with that name for our iterator, which is the same thing as like count here, right? See, count here, same thing. It read clients, int read clients, all right? Not equal to, so while it's not equal to, while it's, like less than, while that number is greater than this one, so and so forth, Of course, this depends on which way you're looping through your elements. In this case, we're going to be going from least to maximum. All right. Clients.end, open close parentheses, semicolon. So remember, this was the first memory address. This is the last data element memory address in the whole list. So here we define the beginning memory address and the ending memory address. And we're going to loop through all the memory addresses until we get to the last memory address in the list. That's pretty much it. And then we're going to say it read clients plus plus, right? Because you would say count plus plus normally inside this for loop. So same thing. It read clients, because remember that's our iterator here. It read clients plus plus. And then close that parentheses. Awesome. And that is how our iterator works. And that's going to let us loop through these different client data objects that we have stored within our list. So essentially this allows us to loop through all our clients that we've added to our list that were valid clients that we found up above, because remember, we added these to our list. If you're forgetting, you can't remember, it's okay, I'll pull it up and show you right quick here. Let's see here, where is it? It is, yeah, right here. Just check it out. Clients.pushback client temp. Remember, we're setting up our client temp. If we accepted a connection from a client and it all worked out fine and went great, we added it to our list, right? Same thing, and we added it to our socket set too. Well, we're going to loop through all those clients that we added to our list. And that's what's going on here. That's precisely what we're going to do. So, with that said, let's get set up with this. Alright, so now we have our iterator, and now we can loop through each client object within our list for our sockets. Alright, so open curly brace here, printf, checking for messages sent by clients, /n/n, close quotes, close parentheses, semicolon. Alright, so that's what we're about to do. So if, parentheses open, SDLnet underscore socket ready, it read clients with arrow towards the socket, close parentheses, right? So we're dereferencing this, and we're using a pointer to reference the socket variable stored within this data element. Now remember, this it read clients is actually pointing to our list item here inside of clients. So I'm not having to actually say clients inside my list. Instead, this actually points to the exact memory address, thereby actually pointing to the actual object stored inside of my list clients. Okay, put this simply, say the first element here in the list, right? This right here is pointing to that first element, right? Because we have clients.begin. It's pointing to that first element in the list. So I don't have to say like clients and then open, close, greater than less than signs, and then put in or like brackets or something like that, and then say it read clients within it like you would normally do with count, right? An array, you'd normally do it something like alright, if this was an array, right, you would normally do something like clients, like this, and then you'd say count like before, right? I don't need to do that because this literally points to that whole thing, if you will, because that points to that element in memory exactly. So I am literally pointing to this item, this element within inside of this list, in this case it would be like an array here, directly, so it's really fast because we're actually swapping memory addresses and not trying to move entire data around. So we're actually just looking right where it is in memory and pulling up its exact location in memory. Cool. So here I'm dereferencing this, and then I'm pointing to the actual location where the socket is in memory within this element. Okay, that said, that is getting past, that socket, is getting passed into the socket ready. So In layman's terms, what I'm doing is I'm checking each client socket that's in my list and seeing if it's ready, if it's, if it's sending something, if I'm receiving something from that client socket. Now remember, above we checked sockets to see if anyone sent us anything, and at this point we did receive something. Okay, so since we received something in there and we have checked it, yes indeed we did receive something from one of the clients. Now we're going in here and finding out which clients sent us something. And that's what this structure does. So, if the client sent us something on this socket, then we are going to do something. So, message waiting sent by client. So we have received a message from a particular client. This is this particular client that we're in for our list, looping through it. And we're going to say if SDL underscore TCP underscore receive, and then open parentheses, it read clients, and then arrow, because we're dereferencing it read clients, and pointing to the memory address for socket, here comma, it read clients, dereference again, and we're pointing to what? The memory buffer. Yes, in memory. So it's very, very efficient, comma. And then 512 here, because remember we defined our read buffer to be the size of 512. So we need to let it know how much we can read in. Okay. Close parentheses, greater than 0, close parentheses. Okay, so what does all that mean? Alright, so we are going out here, we're saying we found out that yes, indeed, this particular client did send us something. Okay, let's go get what they sent us. Okay, that's what that does right there. SDLnet underscore TCP underscore receive basically says let's go get what they sent us. Alright, and then here we're using our iterator to say, hey, we're pointing to the particular client with the socket that had something waiting for us. Alright, cool. We're passing that into our TCP receive. We have to let it know what socket in order to get the information from. And then it read clients here for the read buffer. This is where, so where is the information that we need to get? So here we are, we're passing in the memory address to the actual read buffer that we're going to need to get the actual information from. And we're going to tell it it's the size of 512, so we can receive up to 512 bytes. And if it's greater than 0, then we were successful. If it's less than if it's less than 0, then well, we've got a problem. It's an error. So we've got a result here. So ending this. Oh wow. I didn't think about talking about this earlier, but okay. Ending this is big end and little end, depending on bit order, and this lets us swap around the bit order here. So we're swapping it from little end to big end, BE here. 32-bit, basically element here, or shall we say variable data type, etc. And so we're swapping our bit order around because we need it to be in order to get our conversion to work properly. So that's what's going on here. SDL underscore swap BE for big N 32 here, open parentheses, it read clients, arrow into IP, arrow into host, right? Because we're dereferencing this, pointing to the memory address there, dereferencing that, pointing to the memory address of the host. Okay? So what does this say? It says basically for the particular client in our client list, the IP address, and within the IP address we're actually structure here, because remember IP address structure holds both the actual IP address itself and its port. So we need to point just to the actual IP address itself, which is called host here. So that gets us our IP address exactly, and we're assigning that with the proper bit order that we need in order to do our conversion so that we can display it graphically correctly. So that's all going to get stored into IP convert variable, which is a unsigned int 32-bit variable. Okay, now we need to output the IP address in a let's say human readable format. Okay, so fprintf here, display to the well, kick out a file called standard out, right? Open parentheses, comma, quotes, client, space, %d, dot, %d, dot, %d, dot, %d. Now you remember this is like 192.168.11.132, for instance, which is our client here. And then %u is going to be our port, and we're going to say whatever message that they sent us, and then we're going to say here at the end of that line. So we're going to do IP convert. So same as before, we're just shifting it 24 bits over so that we get what? That first number. So we're taking this number and shifting it over to here, and that pushes all these other numbers off. We just have zeros for the rest of it. Let's just extract this one number. And again, if you remember right, yes, that lets this number here get shifted to the end and basically bump all these other numbers off and leave zeros for the rest. So let's just extract just this number. See, the problem we had before was this was swapped around, so it was little n, meaning that the bit order was swapped, and so this number would be backwards, if you will. So by us doing big N, swapping it around, it made it go back to this direction here so that we do our operations in a logical manner, basically. And for the purpose of us extracting this data, we really do need to be able to do that bit and operation in order to logic operation in order to eliminate the rest of these numbers here, you know what I mean, after we shift it over. So otherwise it's not going to work. So that's really important. So that's why we need to swap our little n and big N for our bit order there. Okay, so 24 comma here, IP convert, shift it 16 bits of course, and then we're going to do our AND what? Our AND 1 byte here for our bit logic operation, which is going to wipe out the rest of the numbers. So again, what's this going to do? This is going to take this number here, move it to the end, and then with our ampersand, with our bitwise AND operation, it's going to eliminate all the other numbers here, and so we just end up with 168 basically left. Okay. Again, IP convert, shift it over 8 bits. Right? So if we're going to shift it 8 bits, what are we doing here? Well, simple enough. We have this 11 here. If we shift it 8 bits, guess what? This is 8 bits right here. So if we shift it over, 11 ends up here. And then when we do it by the AND bitwise operation, that eliminates the other numbers. And we end up with zeros except for this number here. Wrong thing. And then we have just our ampersand with our 111, well, 8 ones in a row for 8 bits, and this is our well, a bitwise AND operator. Since this is the last number, we don't need to shift it. We're already in the right position, right? So when we do their AND bitwise operation for logic opt, it's going to logic hop, same thing. It's going to eliminate the rest of this number all the way together, and so we end up with just 129 period. Awesome. And that leaves us with 192.168.11.132, which is going to be our other client. It's going to be our client because this is a server. It's .129. I know it says 129 here, but that's our server, right? Because if we're connecting, if the client's connecting to us, and our client right now currently is 132 for this last number here, that's why I keep saying 132. Okay. So SDLnet underscore read 16 open parentheses, because remember this is a 16-bit unsigned it for the port. Ampersand to get to the memory address. It read clients dereferenced. Point to the memory address for IP. Point to the memory address would be in dereference for IP thereafter. Points to the memory address of port. Otherwise, if it wasn't for the arrows, this would be a truly nasty structure. It would be really, really ugly. I'm so glad I did these arrows for C++ to help out with that dereferencing and pointing to the memory address. Oh my goodness. Alright, so close parentheses, comma, it read clients, arrow here. So again, we're dereferencing this. Remember, dereferencing means accessing just the actual data and not the actual memory address pointer. And then we're going to point to the memory address of where the data is for rebuffer. Okay, very cool. And that rebuffer here is what is getting stored in our %s. Right, so now we can see what the client said. Alright, and so if you want, I'll do a quick proof of this here in just 1 second. If str string compare, that's what this is, strcmp is string compare, and we're saying read clients here, arrow read buffer, so we're accessing the read buffer of our client that we're currently looping through, right, comma, in quotes, slash exit, close quotes here. So if we see this, we're going to say, if this is false for our, if this comparison is true, then we're not going to do what's below. Should be terminating this connection. Okay, so no, it has to be doing what's below. Maybe this is the problem. All right. Anyhow, we should be doing net quit here. It's true. If I'm even using net quit, I'm not even sure if I'm using net quit anymore. I am not. I can eliminate that really. So I was wondering if I was using it earlier, but that's probably a variable I can honestly get rid of. And let me test that real quick, because I don't want to end up having variables in here that aren't really necessary. And I think that was one of the ones that just wasn't necessary anymore. Like, I used it early on and then I got rid of it later. There's a need for it anyways. Alright, let me just do a real quick save all. I'll just bring it back if it's a problem. Oh, wrong thing. Let me double click on the chat server here. And it's launched. Alright, let's check out the client and make it sure it's working in harmony together. If I remember to put in the correct password again. Alright, so I'm lazy. I'm just going to hit the up arrow and hit enter and say hello. Alright. Whoa. Alright. And so here we see we received something. And check it out. There's our IP address laid out as we expect right here. Perfect. It's in great order where it's easy to read and see. Great. And so we received a message from it, and then we sent the message out to the client here. So here we can see where the client is getting the message sent to them after the fact. And we can see the IP address for each time when we're sending and receiving to them. So very cool. And we can see that the client said hello, and we sent hello back to the client afterwards. Of course, normally you would want to eliminate the actual message going back to the client who sent you the message, as it adds additional confusion to the people seeing what they typed sent back from the server. I'm doing this mainly because you can see if you're screwing up or not easily by receiving messages back from the server. And so that way you know that's working both ways, sending and receiving on both client and the server. So I only did that for basically demonstration purposes here. In a real world situation, you would want to remove the client from being sent the message that they sent you, which is pretty easy to do. Just set like a true false for whether or not to send them a certain message to a certain client, and just mark that client for receiving that message for each message in the message queue. So you can do something like that. It'd be real easy to do. You can mark which one's port, or I mean not port, but IP address shouldn't be receiving that connection, that message, or whatever. You can do some identification number if you want, or ID, client ID, for instance, be a good way to do it, or whatever. It'd be simple, relatively simple compared to the other stuff we've been doing. All right, so this gets us set up, and it shows working here now. And yes, we didn't need that variable. Awesome. Okay. Alright. Quit is the kill word for the server. So see, it terminates the connection. So it terminates the connection to that client. But it's not going to terminate the application, if you will. So yeah, it did say yes on equals equals. So I wanted to show you that yes, it works. So you can see that yes, equals 0 did work. For terminating this connection, I displayed out that terminate connection, like so. You see it right here, terminate connection. Alright, from the client said /exit. So basically you're saying I quit playing the game here online. So for instance, say a player is playing inside of a game, on a game in a channel or a chat room, or from the chat room into the actual game on the game server, right? And they want to leave the game that they're playing online. They would basically send an exit code like this or whatever, and then they have left. And then we remove them. So here we are. We're closing them out from their socket here. So check it out. We're closing that socket. And we are erasing them from our client list. So very cool, as we've closed out the socket and removed it. And probably needs to be removed from the socket set too, actually. I might have overlooked that. Okay, I might pop back in a real quick update and add that in. Yeah, see, we're adding the socket, but it needs to be removed also. And I don't see a socket set being used here to remove. This does close the socket here to that particular one, but I don't know if that's going to remove it from the socket set right away. It still could be stored in the socket set and checking it. Wouldn't be a disaster. The server still work, still run, but it's not efficient, that's for sure, if that's going to be a problem. Close curly brace here, and then close another curly brace there. Okay, so we've removed the client from our list and closed their socket and told us that we're terminating it. Alright, into our standard out file. So fprintf here, sending messages to clients. So that was what that sending messages was a second ago, right? See right here we have sending messages to clients. In the case of sending messages to clients here, we then turn around and actually sent the message to the client and let us know about it. So let's have a look at that real quick. So we did our job for reading in that message, and after we read that message in, we need to immediately turn around and send that to all the clients each time we read in some data so that everyone else gets updated, right? And so for everything we receive once from one client, we need to send out to all the other clients. So that way, think of it like we're doing basically a chat room. Same way though for updating the position of a character too though. So say you have someone type into their message chat box there for everyone to see, you know, because you have messages, teams, etc. typically, right? So this is like for everyone to see, right? You put in they type in the message to send everyone in there, and that gets sent out to everyone else to receive it, because when we receive that message from that player, we need to send that message out to all the other players so that they can see what they're saying, right? So that's what we're doing here. So every time we receive data from one client, we need to resend that out to all the other clients except for the client we receive it from. Now currently right now I'm sending it back to the client we receive it from for our testing purposes and to show that it works. But in real life, again, like I said, you want to leave that person out from receiving the data which they sent you, that sent the server. That wouldn't make sense to send them back that information, because they already know what their configuration are, they already know what they said or whatever. It's right there on the client, so there's no point in sending it back to them. It just eats up more bandwidth and more memory and all this stuff, so there's no point to doing that. Okay, but for testing purposes, there's a point, I guess. Alright, so let's look at basically sending this message out here to our clients. Okay, cool. So printf here, sending messages to clients, ... I'm going to make a slight variation to it. I like that right there. Haha, very cool. Let's do a single one. I don't need a double. Alrighty. And this is your save all button right here. For std : list, open, close parentheses, client type, : iterator. So yes, we're creating an iterator, and it's of what type? List. With list is of what type? Client type for its data types. So there we are. So that sets up our whole type for our variable, and our variable is it send clients. So here's our iterator, and we're going to send it to our clients. And we're going to go to clients.begin for its memory address, and we're going to loop through all our clients here in our clients.begin and send them out that message. So it send clients exclamation mark equals clients.end open close parentheses semicolon it send clients plus plus close parentheses open curly brace strcpy open parentheses here. So remember, this is the beginning memory address here for our iterator, and this is the ending memory address for our iterator. So we're going to loop from the first memory address to the ending memory address of our client's socket list here. Of course, if that client basically was removed from the list, it's not going to get sent out, and they're going to be dead now at this point in time, because they're not going to show up in this list anymore. Clients.end, because we killed that socket. Save the sockets. Clients.end open close parentheses semicolon it send clients plus plus here close parentheses. Alright, so now we're going to iterate plus plus through our memory addresses for each client memory address for each one of our clients that we're connecting to. Alright, so we need to connect to all our clients one by one and send them the message that we just received from the other client. So str copy, so string copy here, right? So we need to copy it send clients here to the sim buffer of our first client one here from it read clients read buffer. Now remember, the read buffer here on my read it iterator, remember, because we have it read iterator, so this is what? A nested loop within a loop with two different iterators going, right? This holds the message that we need to send out to everyone else. So here's the message that we got from our client that we need to send out to everyone else. We're going to copy that into our clients, into the client send buffer to send it out to everyone, to send it out to that particular client. And see, we're going to loop through all our clients, sending it to each client with this single message from this particular client here. All we need to do in order to avoid sending this client its own message is to basically do a check to say, hey, is this client this client? And if they're the same client, then we don't send the message. That's all you'd have to do. It's that simple. So it here space len for length equals strlen for finding the string length, the length of the string here. It send clients, because we don't want to send more data than what's there, right? We want to be efficient about this and send as little as possible. It send clients here, arrow here, because we're dereferencing this and pointing to the memory address here. Send buffer here. So for this particular client, it's send buffer. String length plus 1. So we're going to get the string length plus 1 to it for len. Don't forget there is a /0 there for the termination character. So getting sent for the string. So there's always one more than you think. And it starts at 0 too. Don't forget about that. If open parentheses SDLnet underscore TCP underscore send here, open parentheses, it send clients here, arrow socket. So what we're saying, we're going to say SDL TCP send. We're going to send a message out to a client. Which client we're sending to? This one right here, and at their socket. That's where we're going to send it to. Void star here, so we're going to return nothing. And we're going to do the actual data of this thing. So dereferenced. It send clients here, arrow pointing to the memory address of sim buffer. So again, we're accessing what? The sim buffer here. So we're saying, which client is it? Which socket are we sending it to? This one. What message are we sending? This one right here. This is what we're sending. And how long is the message? This one right here, len. Alright? If this is less than, this whole thing comes out for our return value is less than the length, then we are good to, then we have an error. Sorry. Basically, we weren't able to send the message if it's less than this. fprintf here, standard error, std error, comma, open quotes here, SDL net, sorry, underscore TCP underscore send colon %s /n close quotes comma SDLnet underscore get error open close parentheses semicolon. Then we're going to do exit open exit underscore failure close parentheses semicolon close curly brace. So that lets us send out that message. Then we're going to get to our else curly brace here. And then we're going to do our swap of our big endedness with our little endedness. So remember, big end swap here. And we're going to have our it send clients here to IP host. Right, so we're getting to our actual IP address. IP address here with the swap here. IP convert is stored into that variable. fprintf here, standard out to client, and then their IP address being converted with our bit shifts and our logic opt and operators for our bitwise and logic operators. There we go. Set it properly that time. To client %d.%d.%d.%d, right? So like 192.168.11.132, for instance. %u for the what? The port. Yep. Here comes the port right here. Bang. There's the port. %s for what? The message that's being sent. And semicolon. And if you have multiple clients up there, it'll tell you which client it's sending to for each client, and actually go through and tell you that's sending it, and then each client will receive this message. So it's pretty cool. It works. Close curly brace, close curly brace, close curly brace. Close curly brace again. This is a massive structure. You can see how it is actually going across here. So, you know, going through the different ifs conditions there. Should we send it to someone? Should we do blah, blah, blah? All this stuff. For each one. Again, that's our if, as whether or not we actually received information from that client. And then this was our for loop for sending it. And then this, of course, was our else. So that's why we have the 4 closing curly braces. Yeah, I know, it's multi-nested, big time. SDL underscore event, space event, semicolon, while SDL underscore pool, event, open parentheses, and event, close parentheses, open curly brace here, when we do our checking for if there's been keys pressed. Switch, open parentheses, event dot type, close parentheses, close open curly brace, sorry. Case here, SDL underscore key down, colon, if, open parentheses, key dot event, event dot key sim dot sim equals SDLK underscore escape, close parentheses, open curly brace, app quit equals true, semicolon, printf, in quotes, ESC, quit key, close parentheses, so that we know that it's quit. So say app is true here, close parentheses, semicolon, close curly brace, case SDL quit, SDL underscore quit, colon, app quit equals true, break, so basically if someone clicked on the little close button, this would be the SDL quit, close curly brace, close curly brace, close curly brace. This curly brace is referring all the way back up to this while loop for the entire checking for the clients. So essentially, if we get in that app quit, that's going to end this loop altogether, and which basically ends our server. So what we need to do now, we need to do TCP close for the server socket. We need to free our socket set, and we need to do an SDL underscore quit, open close parentheses, semicolon. Alrighty. And looking at this, I feel like I've left out deleting memory addresses for my list that I created. Yeah, so I'll probably need to loop through that list and delete all the memory addresses for the clients, otherwise I'll be having a memory leak here. It won't be much of one, but still be a memory leak. So just notice that. Yeah, I think that's the case. Okay, so we'll pop back in here in the next video and do an update on this.